Hey everybody. Um, this is the last section for this exam. There's technically one more section after that, but I'll talk about that after your exam on Thursday. So, this last section is pretty short. Well, it's only 4 pages, and it's over how to manipulate equations, and then how to create your own equations based on a word problem. So, this first question says, given the regular compounding formula, solve for t. What they mean is don't plug anything in and solve for t. And so, if you look at this equation is, the main idea is multiplication. You have p, thing 1, times thing 2. So you're multiplying these two things. So the first thing we're going to do is we're going to divide by p. I want to get the expression with t all by itself. So a over p equals 1 plus r over n raised to the nt. Okay? Now think of this, usually the 1 plus r over n throws people off. What I usually tell people to do is think of it as it's your base. This number is just your base. And you have an exponential equation. And you're solving for t. Okay? So the way that you can do this is we log both sides, just like we did in the last section. If you want to solve an equation, we want to solve for t, but in order to solve for it, it can't be an exponent. We have to bring it to ground level. And so the easiest way to get something to ground level is to take the log of both sides. So I have a over p. I have to the nt. I'm still just going to write this as base to the nt. Make that go away. Okay. And now what that allows us to do is we can now get the exponent and bring it to the front. So I have log of a over p equals n times t times log of, and this time I'll write the base. It was 1 plus r over n. Okay. So now I want to solve for this guy. And so how do I solve for it? Well, let me rewrite it again. Instead, though, I'm going to write this as t times n times log of 1 plus r over n. All you got to do now is divide by everything that isn't t. So those cancel out, and you end up with your answer. So the solving process, when you're solving the compounding formula for time, this solving process is the same every single time. But on your homework, the first couple questions want you to solve for certain variables. So your final answer is going to be t equals log of a over p over n. It looks really nasty, but hopefully it wasn't too hard to solve. Okay. Now, if you had used natural log instead of log, your answer would have been pretty much the same thing. It would have been just with ln's. So the log or natural log, whatever you use, it doesn't matter. You're going to get the same answer. All right. So next one. What about the continuous equation? Well, since this one has an e in it, it's going to be best to use natural log. Because the ln and e are inverses and they'll cancel each other out. So for this one, the first step you're going to do, same as before, I divide by p. And we divide by p because, remember, there's two things being multiplied. P times e to the rt. And if we're going to do any logging, that p needs to be, or the e to the rt has to be by itself. And since it's e, I'm going to do the natural log of both sides. So I have a over p, e to the rt. Right? Now the ln and the e cancel each other out. And so you're just going to be left with rt. But if you don't see that, the same thing tends to happen, or the same thing happens. The rt jumps to the front. So we have ln of a over p is equal to rt times ln of e. But ln of e is 1. So the answer becomes ln of a over p equals rt. And to solve for t, we just divide by r. Notice that this answer is a lot nicer than the previous one because of the ln and the e canceled out. So I have ln of a over p divided by r. So this formula, so basically what we have here are formulas. Whenever you're doing continuous compounding, some people hate solving so much that they tend to memorize these. But when you're doing continuous compounding, there's a formula for t. If it's just regular compounding, there's a formula for t. Now, as for me, I'd rather know how to solve it than to memorize formulas. But if you just want to memorize those formulas, I'm not going to get mad at you. On your lab, though, they do want you to solve it with the formulas, though. On the exam, if you just use those formulas, I won't mind. But on the lab, please, please, please solve it. Okay. So the next one says, given Q equals, now this is our first time seeing this guy, maybe not the first time, but this Q, 0, this usually means Q at time t equals 0. Okay. Another word for it is it's the initial value. And usually what I call it is I just call it Q naught. Or you can call it Q sub 0. Subscript, sub for subscript. And then it sounds like a Mortal Kombat character, but however you want to say it. Usually I'll just say Q naught. So we want to solve this equation. What I want you to notice is that this equation, Q equals Q naught e to the negative kt, is very similar to A equals P e to the rt. Notice that there's a relationship between the two. They're actually exactly the same equation. The reason why they're written differently, though, is different fields of math use different variables, and so they call them by different things. But these equations are exactly the same. So if I solve for t, I would end up getting the same thing. Why is my screen not moving? There we go. That I got over there. ln of, and this time instead of a over p, it would be q over q naught. Instead of r, it would be negative k. But I just want you to know that they're the same equation. In math, or when you're dealing with money, you tend to use this formula. When you're dealing with populations, you tend to use this formula. Whereas this one is used for finances. Okay, so different realms of math have different equations, but pretty much the same thing. So let's get to it. Let's solve for k. My screen is being very unresponsive today. Why? I don't know. Let me see if I pause. Let me pause it real quick so I can get it up and running. All right, so my touch isn't responding very well, so I'm going to use the keyboard and mouse to kind of zoom in and do stuff. So anyway, we're going to solve this. It's a lot harder to pinpoint an area when you can't use the touch screen. But anyway, we'll start with our equation. And they want to solve for k. Right? So again, what we have here is two things that are being multiplied. Thing 1 times thing 2. In order for us to use log, the exponential term has to be by itself. So I'm going to divide both sides by q naught. And so I have q over q naught equals e to the negative kt. Just like before, I'm going to use natural log on both sides because the base is e, and ln and e cancel each other out. Right? Let me shrink things a bit. So again, you can write the ln and e just canceling out. That's fine. Usually during stress situations, people don't see that and they bring it to the front instead. It's up to you. So we get negative kt times ln of e, but again, ln of e is 1. So you have ln of q over q naught equals negative kt. And I'm going to move my work over here because I ran out of room. Let me rewrite that. And so to solve for k, notice that we got to get rid of the negative sign too. So let's just get rid of both at the same time. I'm going to divide by negative t. Negative t. Those cancel, those cancel. And so I have k is equal to, it's bad manners to have the negative on the bottom, so I'm going to put it on top. Negative ln of q over q naught to the t. There's more stuff you can do if you want to be fancy. Technically, the negative would flip the inside of that, but I'm not going to go there. I'm just going to say that's my answer. And so if you wanted to, this is a formula for k. Now, I prefer that you just memorize the solving process. It's not too difficult. All right, let's go to the next page. Or not next page, but the last one. This one says solve for d. So, in order to solve for d, I have to get this log by itself. But there's a couple things happening. There's addition and there's multiplication. So I'm going to subtract the 8.8 first. And I have m minus 8.8. And we have 5.1 log of d. Now, again, I need to get the log of d by itself. So I have to divide by 5.1. Those cancel. I have m minus 88 over 5.1 equals log of d. All right? Now, remember that if there's no number present on the bottom, it's going to be a 10. And so all we have to do now is convert. Okay, so when you convert, the base stays the same, except now it's a big number. The answer, so the answer goes on the inside. So here's the answer. And the inside becomes the answer. So 10 to the m minus 88 over 5.1, all of that is an exponent, equals d. That's it. Okay. So in the next problems that we're going to solve, they're pretty much just like these, except that there's going to be numbers for all the letters that we're plugging in. A is going to have a number, P is going to have a number, R is going to have a number, but I'm still going to do the same steps to solve. So let's go to page 2, word problems. Suppose that $11,000 is invested in a bond fund, and the account grows to $14,025.40 in 4 years, compounded continuously. Determine the average rate of return. Okay, so this is a money problem. Money problem means we're going to be doing A equals P. They said compounded continuously, so e to the RT. Okay, in addition to that, we know that $11,000 is invested. That's the initial amount, so that's going to be my P. The final value, that's going to be my A in 4 years. So there's your T. And the only variable that we don't know is R. So find the average rate of return. So they're telling us to solve for R. Okay. So to do that, I have A, 14,000. Usually we don't put the commas when you're doing the math because it just gets confusing. 14,025.40 equals P, 11,000. You can put the commas if you want. I don't know. I'm just kind of mumbling. 11,000 e to the r times 4. So I just plugged all my numbers in. Let me rewrite it again. I don't know, for some reason, have you ever had those moments where something just doesn't look right to you? For some reason, the comma just doesn't look right. It's like, I don't know. Hi, phone. So I wrote it as 4r, and we want to get the r by itself. So just like in the previous page, before I can do anything, I got to get this term by itself. So I divide by 11,000. I divide by 11,000. Okay. So notice that there's no calculator yet. Don't put that in your calculator because you're just going to get another rounded answer, and then it just, as you do more and more, the answer gets more and more incorrect. So I have e to the 4r. Since it's e, I'm going to natural log both sides. So I have 14,025.40 over 11,000 equals e to the 4r. The 4r is able to come to the front. And so we have 4r ln of e. ln of e is 1. So write it all out again. Notice that I haven't used a calculator yet. Equals 4r. And so my last step is to divide by 4. So on the exam, when you're looking at the question and it's a multiple choice question, all of the answer choices are going to look like this. $14,025.40 because we want you to actually solve it, not just plug it into your calculator. All right, so this is what we call the exact answer. But you get your calculator, plug it in to get the approximation. So ln of 14025.40 divided by 11,000 divided by 4. So 0. And this, remember, this is going to be a number that we convert to a percentage. So I'm going to do 4 decimal places, 0.0607, so that I can convert that to a percentage, 6.07%. Okay, so the rate of return is 6.07%. All right, I want you to notice how solving this was exactly the same as solving this one up here. All the steps were exactly the same. And notice that the formula, ln a over p divided by r, well, r and t are next to each other. So instead of dividing by r, I just divided by t. But ln of a over p over r, and then you go down here, ln of a over p divided by, and instead of r, it's just the t. So the formula still holds up, but knowing how to actually go through the motions is a huge skill for this exam. All right, Next question. Suppose that P dollars in principal is invested in an account that earns 3.65% interest compounded continuously. At the end of 7 years, the amount in the account has earned that much money. What was the original investment? So we know a couple things. So compounded continuously at the end of 7 years. We know the rate, and we know the final amount. So in my equation, A equals PE to the RT, I know everything except for P. The final amount is 1,437 and 20 cents. P, I don't know. E is just a number. R, oh, there it is. We want to convert that to a decimal. So 0.0365. And then 7 years, so times 7. All right? Now, notice that this problem, I have two things being multiplied to each other. And I want to solve for P. Well, P has nothing to do with that exponential. I can just divide by all of that. And those cancel. And you get P is equal to 1437.20 over e to the 0.0365 times 7. And they didn't tell us how much to round to, but we should know how much to round to. When you're dealing with money, money is 2 decimal places because you can't go smaller than a penny. 1437.2 divided by e second ln to the 0.0365 times 7. Close it. And you get 1,113 and 15 cents. Also, for international students in the U.S., it's customary to put the dollar sign in front of the amount, not at the end. However, if you're doing cents, like 43 cents, then that goes at the end. But if you're saying $2, it goes in front. I don't know. That's just something we do because we're a crazy country. All right. Anyway, so this one was actually easier and didn't require any actual log stuff. So what if it had been done? What if it was compounded monthly? Then the equation would have been different. The equation would have been P1 plus 0.0365 over 12 raised to the 12 times 7. So the equation would have been completely different. You would have used the compounding equation, but it's still two things being multiplied. And even though that whole thing looks nasty, you still divide by all of it. Six five over 12 raised to the 12 times 7. So those cancel. And the value you get for P, if it's compounded monthly, is this. Okay, so this is the exact value. And if I put that in my calculator, 1437.2 divided by, now here you have to open up the parentheses, 1 plus 0.0365 divided by 12, close parentheses, caret, open parentheses, 12 times 7, close parentheses again. And notice that we get pretty much, 1,113. But this time it's 59 cents. Ooh. So how much more money did you have to put if it's compounded not as often? Turns out you only had to put in like 50 cents more. That's it. All right. Anyway, I wanted to show you one with that equation. All right. So let's keep chugging. The population of 2 countries are given for January 1st. So there's this problem is some very similar problems on your lab. So please, this one. Okay. Use the information to create an exponential model. So we're going to create a model of the country, and we're going to do each one separately. So each one's its own problem. I'm going to call this problem A. I'm going to call this problem B. So for A, Switzerland, we know this 7.3 and the 7.8. Well, this is my initial value. Here's the formula they want us to use. Okay. Well, before I start, let's talk about this formula. So P of T is like saying, it's like saying f of x. It's not f times x, it's f of x. So this is P of T. If the of T throws you off, especially this close to the exam, what I would do is, I wonder if I can do it here. Select color. I'm going to temporarily change it. So if that of T throws you off, what you could do is just pretend it's not there. Just P equals P naught e to the kt. All right? Where, now let me change this back to an actual color. Wonder if it's going to bring it back. Okay. So where this one is the final value, and this one is the initial. So here we have the final value. Oh, sorry. The initial value. Here we have the final value. And we know that it's from 2000 to 2010. So I know that T is equal to 10 years. So I have everything I need. Notice that I have the P, I have the P naught. I already know that T is 10. All I got to do is solve for K. So let's write it out. So for the first one, P is equal to 7.8. P naught is equal to 7.3. T is equal to 10. So I can plug all that in to my formula. So 7.8 equals 7.3 e to the k times 10. My first step to do is to divide by 7.3. No calculator yet. E to the 10k. Now I'm going to natural log both sides. ln of ln of and I have 7.8 over 7.3 e to the 10k. The 10k comes to the front. Forgot to put an equal sign. ln of 7.8 over 7.3 equals 10k, and then the ln of e cancels out. So ln of 7.8 over 7.3 equals 10k, so my last step is to divide by 10. All right, so k is equal to, I was trying to fit it in that line. All right, and so k is about equal to, on the exam, I think they want you to write it exact. On the homework, you have to be careful. What I usually do is I have ln of 7.8 divided by 7.3, and close it, divided by 10. And notice that it's going to be a nasty number. Rounding is very, very dangerous when you're dealing with exponentials. So when you're doing this, we don't want to round. Don't round the rate. Okay, so instead what you do is in your calculator has a fancy store button where you're able to store up to 26 different values for use later. And so in your calculator, well, if you want, you can just write it down. Write down the entire number. But in your calculator, you can have, let's see, you just press the store button, and then you pick which letter you want. Notice you have all the letters, they're in yellow. And I'm going to pick the letter K. Not in yellow, sorry, they're in green. There's K. So alpha, hit enter. And so now whenever I do alpha K, it knows what number that is. All I got to do is type K. So I can say 10K, and it multiplies it by 10. Anyway, so I'm not even going to write the decimal answer here. I'm just going to say that this is my answer. So on your problem, it says P equals P naught. And notice, oh, I did say round K to 5 decimal places. Sorry. And that's the cool thing. I don't have to redo the problem. I just do alpha K. 100662. So, sorry. The actual formula for the equation, they want you to plug in the P naught, 7.3, e to the 0.00662 t. And that's the formula that they're looking for. So on that problem on the lab, it's pretty much the same thing. I give you the starting value, the ending value. You already know how long, over what period it is. And all you do is plug it in, solve for the rate, and rewrite the question with the rate plugged in. P So my answer is P equals 7.3 e to the rate times t. On the homework, I think they want you to put it exact. So they would want you to write P equals 7.3 e to the, and then it seems kind of silly, but I guess they just don't want rounding errors. So 7.8 over 10 times t. Seems kind of silly writing it like that, but on the homework, on the lab, I think that's what they want. All right. Anyway, so that's B, or sorry, A. I'll save part B as an extra example. It's exactly the same thing. I'll post it on Canvas below this lecture. And so I would give it a try. Try it and see if you get the right answer. Watch the video and be like, yay, I got it right. I'm ready for this test. Okay, so this next one is refer to the model. So here they give us the equation. That's good. For the following example. At the Marmsman Archaeological Site in southeastern Washington State, scientists uncovered the oldest human remains yet to be found in the state. A sample from a human bone taken from the site, misspelled it, showed that 29.4 of the carbon-14 still remained. How old is the sample? So what's tricky about this is it seems like they're not giving you enough information. You have, remember, if you don't like the of t, you can just ignore it. Q equals Q naught e to the negative 0.000121 t. So they don't give us an actual final value. They just say that 29.4% of the carbon-14 still remained. Okay. But this actually tells us what it is. So it's 29.4% of the remaining portion. Of initial value. So this is 0. Oh, sorry, not yet. But the initial value is Q naught. That's what that's what the naught means. It's where it starts. Sorry, I feel like I'm not doing a very good job right now. 29.4% of Q naught. Well, I can convert that. That's just 0.294 times Q naught. So it turns out that this is my final value. And with that, we're able to actually solve the problem. So when we have Q equals Q naught, e to the negative 0.000121 t, this is really 0.294 Q naught equals Q naught e to the negative 0.000121 t. Okay, I don't know what the initial amount was, but it turns out that it doesn't matter. Because if you remember the first step is to divide by Q naught, and the Q naughts are going to cancel. Dun, dun, dun. So I have 0.294 equals e to the negative 0.000121 t. And then I take the natural log of both sides, as one does. Okay. You've hopefully seen this enough times to know what's going to happen. The ln and the e are going to cancel. And I did not give myself enough room. Okay. So you have ln of 0.294 equals that comes to the front, 0.000121t ln of e. But like before, the ln of e cancels out. So you got ln of 0.294 negative 0.000121t, and so you would divide by that small number. Yay! So there you go. And so when you plug that into your calculator, you have ln of 0.294 divided by negative 0.000121. And notice we get 10,117.15. Now here they don't really want us to be that accurate. How old is the sample? We'll just say the sample is 10,117 years old. Yay! So the trick for this one was not freaking out that they didn't give you a final value. We have 29.4 was really 0.294 times Q naught. And then in the first step, the Q naughts cancel. Because, yeah, they cancel. I don't know why. Anyway. And then from there, you can solve the problem, just like you normally would. Now, this idea is actually cool. This is what we call carbon dating. So what scientists do is they find a sample, and so as long as you're alive and breathing, your body generates carbon-14. When you stop breathing, when you pass away, your body stops producing carbon-14. It's still there though, and it has a very predictable decay rate. And so what they do is whenever they find bones or something, they find the amount of carbon-14 and they compare it to the amount that's already in a living specimen, and they can that's the sciencey part. And they'll say, oh, there's 29.4% left. And from there, you can do the math. You figure out how old it is. Now, if it's really, really, really old, carbon dating doesn't work anymore, and it's not accurate. You need to find a different element with a slower decay rate. But anyway, I'll stop being a nerd. All right, last two problems. Half-life. Half-life, fun video game. So half-life is the time it takes for, drumroll, half of a substance to decay. So when t equals the half-life, so the half-life is a time. So when t is equal to the half-life, Q is equal to 1/2 of the initial value. This isn't, it's times right here. That's supposed to be multiplication. So 0.5 Q naught, if that makes sense. Or essentially, I plug in t equals half-life. I get 0.5 Q naught as an answer. So if from a math perspective, that's what half-life is. You plug the half-life in, and there's half of whatever it was. So if the initial amount was 10, you plug in the half-life, the answer will be 5. Okay. If the amount was 100, you plug in the half-life, you get 50. And then if you plug in twice the half-life, it'd be 100, 50, and then it keeps halving itself. 25, 12.5, 6.125, so on. All right. Anyway, let's get to this word problem. The isotope of plutonium-238 Pu, I don't know how to say that, is used to make thermoelectric power sources for a spacecraft. Suppose that a space probe was launched in 2012 with 2 kilograms of it. If the half-life of that element is 87.7 years, write a function of the form meh to model the quantity left after t years. All right. So half-life is 87.7 years. So that means that when t equals half-life, or sorry, when t equals 87.7, that means that Q, remember Q is the final answer. When t equals 87.7, Q is equal to 1/2 times my initial value. And they actually told me in 2012 there was 2 kilograms. So that's 2. Well, what's 1/2 of 2? 1. So those are my values. When t equals 87.7, Q is 1. I already know my Q naught, and so now I can solve for K. So we rewrite the equation. I know Q. I know Q naught. E to the negative KT. So negative K and T is 87.7. Let me just rewrite it real quick. Negative 87.7 K. And so I want to solve for K. So the first step, divide by 2. You get you guessed it, 1/2. And we have e to the negative 87.7 K. Natural log both sides. Yeah. Okay, the ln and the e cancel out. So hopefully we've seen it enough to just know that those ln and the e go away. ln of 0.5 is equal to negative 87.7 K. And then I can divide by negative 87.7. And there's the value for K. I didn't get myself enough now. Story of my life. Hold on. There's my mouse. Guys, I was so excited that I finished grading an exam for my other class that I almost forgot about y'all. I was already getting ready to sleep, and I was like, I didn't even make the lecture. I'm terrible. I let you down. Okay. So K is ln of 0.5 over negative 87.7. And in the spirit of all the other problems that we have done, we're going to do 6 decimal places. ln of 0.5 divided by negative 87.7. So 0.007904. So your final answer is to rewrite the equation with the proper variable. So can't fit anything. I'm sorry, guys. Okay, so your final answer is just to rewrite the formula. So your final formula is Q is equal to Q naught is 2 e to the negative 0.007904 t. Remember, the negative was part of the formula. I'm just repeating this formula with my Q naught, and the whole part was to figure out what K was. Once they give you the half-life, you have enough information to figure out K. Yeah. Last problem. Guys, it's the last problem. So fluor blah 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 is a derivative of glucose that contains the radionuclide, whatever, fluorine 18. A patient is given a sample of the material containing 300 mbq. The patient then undergoes a PET scan to detect the areas of metabolic activity indicative of cancer. After 174 minutes, 1/3 of the original dose remains in the body. Okay? So it turns out you're given this from the initial function. So this 1/3 is kind of like the half-life. Where was it? Oh. So they're saying that when t equals 174, okay, then Q is equal to 1/3 times Q naught. Now, they don't have to give you Q naught. Before I even start the problem, they don't have to give you Q naught, because when you write your formula out, if you write the Q as 1/3 Q naught, notice that the very first step is the Q naughts cancel. So sometimes when you do these problems, they don't even give you Q naught because they don't have to. Now this one was nice, and they gave you Q naught. So they gave us 300. So let's go ahead and work that out. So Q is equal to 1/3 times 300, which is equal to 100. How nice. So I know my variables now. I know T is 174, Q is 100, Q naught is 300, and now all I got to do is solve for K. So 100 is equal to 300 e to the negative k times 174. Okay, my first step is to divide by 300. So 1/3 e to the negative 174k. And now hopefully you've had enough experience with this to kind of know what to do. We just natural log both sides. And so you get ln of 1/3. That's what you get from natural log in the left, equals ln of e to the negative 174k. And we know that the ln and the e will kill each other. And so we just divide by negative 174. So K is ln of 1/3 divided by negative 174. Put that in our calculator. So 0.006314. All right. So my equation is going to be Q equals 300. E to the negative 0.006314 t. There you go. So the final answer, all they want is the only variable that you can have is t. So Q, which is the final answer, is equal to 300 e to the kt. Again, the negative sign is part of the formula. All right. Now, what's the half-life of fluorine 18? Okay. So the half-life is how long does it take for half to remain? So if Q naught is equal to 300, then that means that Q should be equal to 150 because half-life. And we already know what K is, so this one's actually not too bad. We rewrite the equation. 150 equals 300 e to the negative 0.006314 t divided by 300. Get 1/2. I know if you Google this stuff, you'll find formulas for half-life. Okay? I would prefer that you actually go about solving it by hand. Okay? Don't just be like, oh, look, I found a formula, let me use it. I want to see that you actually know how to solve an exponential equation. For t, the ln and the e cancel each other out. And so I have ln of 1/2 equals negative 0.006314 t. And all I got to do now is divide by that really small number. So ln of 1/2 over negative 0.006314. And so we type that in our calculator, and that's going to tell us how many minutes it takes for half of whatever that substance is to decay. Negative 0.006314. So 109.78. So it takes about 110 minutes. And so the question was, what's the half-life? The half-life is about 110 minutes. All right. This section tends to be difficult for people for two reasons. One, it's at the end of the exam, and so there's less time to study for it. Two is people freak out when they see word problems. Now on the exam, the last couple questions are going to be from here, so please work on your lab and please do the homework before even attempting the exam. Okay, because you are going to see questions like this, and they're going to be very similar to these questions. For example, question 6, that's a good test question. Question 3, ooh, that's a good test question. Right, and let me pause it real quick because there's one more thing I want to tell you, but I got to bring it up on the screen. All right, I sent y'all an email about the exam and next week's final. And so this is the email that y'all should have gotten. So this week is exam 4. It's going to be Thursday and Friday because I know all your classes, everyone's trying to cram in their exams before the end. But the final exam is going to be next week. So at the very end, I tell you that, or not tell you, but I'm kind of pointing out that Collin College does have a math lab. And when the whole pandemic thing started, the math lab emailed everybody. But I just want to remind y'all that they're still there. So if you click on them, okay, so you have online tutoring. Well, not now. Oh, there's the math lab. And Plano. Okay. So the math lab is actually online. And you I guess you create an account. Yeah. So they tell you to go to the website, create an account, but they're able to help you remotely. You show them the problems you're working on, and they'll do what they can to help you. And also, I'm here during my office hours to help you out as much as I can. Um, so please, I know this is kind of freak out time, but if you have any questions, please let me know. I'll do everything I can to help you out. All right. Have a good one and stay safe.